Okay, next problem is 71, right? So let us look at the problem number 71. It is from AC, alternating current. And what is the problem trying to tell you? It is trying to tell you that you have an arc lamp, 10 ampere 80 volt. So obviously that will give you the resistance of the filament of this particular lamp. But now you want to operate this with alternating current. Okay, so it's a typical question of a choke coil, right? So the first data tells me that 10 ampere of current is 80 volt. So 80 volt is the voltage to 10 ampere current. So I'm sure that 8 ohm is the resistance corresponding to this particular filament. Now I want to operate it on 220 volt. I want to operate it on 220 volt RMS. And then I'm using 50 hertz supply. 50 hertz is F. So omega will be equal to 2 pi F, that is equal to 100 pi. And then XL will be equal to omega L, that is equal to 100 pi L, right? Okay. So now what do you want? What you want is this current 10 ampere should is the maximum current this particular filament can handle. So we know what is to be done now. You want to keep the current limited to 10, but you want to apply 220 volt. So 220 volt should be taken care of by Z. You know what Z is? Z is equal to 220, and this term will be XL square, that is 100 pi L whole square, plus the resistance that was there, that is 8 ohm, so this will be 8 square, right? So I can lose the 0 with 0, square it up and solve it, you get 484 is equal to, this term will come here and will give you 10 to the power 5 L square, and this term will be 64. Bring it this side, 420 is equal to 10 to the power of 5 L square. So 42 by 10 to the power of 4 is L square. 42 and 10 to the power 4, so this is 10 square, 100. 42 is around 6.5, 36 and then 49, okay, 6.5, so this comes out to be 0.065. 0.065 Henry. This should be the possible answer. That is your answer number 3. Very simple question. Okay, 72. A pipe open at both ends has a fundamental frequency F in air. Here is a pipe. It is open at both ends. Antinode will be formed here. Antinode will be formed here. You know the frequency is F, that is equal to V by 2L in this particular case. Now what you do is you put some water in this, so this becomes L by 2. You will get a node here and you will get an antinode corresponding to this at this particular point. You know the fundamental frequency formula of closed organ pipe is equal to V by 4 L prime, but the L prime is reduced to L by 2. You see this term also is V by 2L. From here I know that this term V by 2L is called F. So F prime will be equal to F, no change, right? So that reduces to the answer, and the answer here would be 3. Okay? Right. The next question is from diffraction. Pinhole camera, length L, hole of radius A. Now when I look at this problem, if the radius is given as A, then this is a circular hole. If it is circular hole, that 1.22 lambda, that term should be taken care. But looking at the answers, I think we'll have to take it as a straight slit. Okay. So let us see what the problem is trying to tell you. It is trying to tell us that you have a situation where you have a camera, pinhole camera, and then there is a screen out here. This is L distance, and let us say the radius of this is this, so this is equal to 2A. Okay, this is the center line, maybe like this. If this was too broad, you know the light will come and you will get here the light in this particular zone, that is equal to 2A. But what would happen here, because of the diffraction, the light will go and encroach into these areas here, and of course this side. What is the formula? The formula is 2A sine theta. For this, if you look at it, 2A sine of theta is equal to lambda, n lambda. So you get sine of theta or let us say for small angles theta is equal to lambda by 2a. Okay, lambda by 2a, and then we know this is y by L, so this becomes y, this distance I call as y, so this becomes y equal to lambda by 2a and L lambda by 2a. They have given us the B. Okay, the B is what in this question, if you look at it, they have given you B as the spot would have the minimum size. So they have given you the minimum size corresponding to this one. So that would be equal to this plus this. So this is 2a and 2 times y. So B is equal to 2a plus 2 times of what we have calculated here, that is lambda a by 2a, right? And now if you look at it, we can get a quadratic going. This is B, 2ba is equal to 4a square plus this you can lose here, this you can lose, this will be L, and there is a lambda term, this is lambda not a. So this will be L lambda, and 2a I have already taken LCM and shifted this side. Alright, so let us calculate here first of all for the a. So a will be equal to 4a square minus 2ba plus 4 lambda. L lambda should be 0. So for real roots, if we solve b square, that is 4b square, 4b square minus b minus 4ac should be equal to 0. So this 4 and 4 you can send to 0, and b square becomes equal to 4 lambda L, and b becomes equal to 2 under root lambda L. So b is equal to 2 under root lambda L, or let us say 4 lambda L is b is equal to 4 lambda L. This is the answer. Now it is coming only, okay, it is coming in 2. So we also have to calculate the value of a. So that can be substituted, b can be substituted out here in terms